Hello YouTubers and fellow 3D printing enthusiasts. So back a few videos I tested an antenna and Faraday, and for testing that antenna I made a little fixture that I put on the end of a PVC mast that I use from time to time. A little threaded fixture that allowed me to hang a carabiner on the mast. There was some interest over in the Facebook page and over on my Patreon page in how I did the custom threads in FreeCAD on that piece. So I thought I'd go ahead and do a little tutorial on it, my first FreeCAD tutorial. Now I'm learning the program myself, so some of the ways I do things might not be the best ways. Those of you that are far more experienced with CAD, take it easy on me. But I think I did okay. So we're going to go to the computer, we're going to load up FreeCAD, and we're going to talk about how we did custom threads in this model. For those of you that are already familiar with drawing and creating simple parts in FreeCAD, if you just want to jump ahead to doing the threads, there's going to be a link over here of the time signature in the video where we do the threads. For the rest of you, I'm going to go through some of the basics of creating the part in FreeCAD just so you get an idea of how to do things in FreeCAD. So let's go to the computer. Okay, before I even start designing, I need to examine this threaded piece that I have glued on the top of the mast. This is what I'll be threading onto. So I need to make some measurements. I need to know, how far out my hole is going to have to be for the carabiner to clear this. I need to know the diameter of the outer part of these threads and the inner part here of this solid area, so I can figure out information about the threads and how big my part has to be. So I got my calipers out and I went and did some measuring. One thing also on the threads is I needed to know some data on thread pitch, which is the width of the threads. And the only thing I could find on this part was that the threads were 14 threads per inch. Now, I'm in the US, and this is a US part, so they're using imperial measurements, inches. And I'll have to convert some things there to decimal or to metric because I model in metric. It's just easier for me to model in base 10. You can model in whatever format you want. So anyway, I did some measurements with my calipers. I discovered that this inner pipe, or this inner solid section, was 21.5 millimeters, and out here to the threads was 24. At this end, down here, but when I got over to this end out here, it was 24.4. So there's a slight taper in this thing. So what I'm going to do is probably target the bigger dimension down at this end of the pipe here for my dimension. So it'll thread on a little loose at the beginning and it'll tighten up as we get down to the bottom. The depth of this thing is 20 millimeters total, so I'm going to make my part about 10. I don't need to engage the entire thing. That'd be overkill. So yeah, I've got some dimensions there. And as I said, the other thing I needed to know was the threads. Now the thread profile, which is the shape of the threads, if we look up here, it's a triangle. These are injection molded, they're not cut. But if we were cutting these threads, you can clearly see it right here. This is a triangle shape. So that's going to be our thread profile. The other thing we needed to figure out is the depth of the thread, which we kind of have with these two dimensions right here. Now these are diameters, right? So if we're going to figure the depth of the thread, we have to cut these in half and just look at the radius. So I did a little math. 12, which is half of 24, minus 10.75, which is half of 21.5, gives us a depth of 1.25 millimeters. So that gives us what we need on the threads. Let's go and look at that. So we know it's 14 threads per inch, right? So we did a little math here. That means the pitch is 1/14 of an inch. So 1 divided by 14 would mean that our pitch, the width of the thread, is 0.0714 of an inch. Converted that to millimeters, and we get a thread pitch of 1.814 millimeters. That's the width. We got the height. And we have the profile. We have everything we need to make threads. So I guess we have our dimensions. It's time to go into FreeCAD and start modeling. So here we are in FreeCAD. I am using Release Candidate 2 for version 1.0. You can see up here. They're moving right along. First we got to start a new file, obviously. And we're going to be making a parametric part. Now this will start us up in the part design workbench. There are several workbenches in FreeCAD for specialty things that you might want to do. Each one has a different set of tools that come up here. We're not going to get into all of that detail. We're only going to be working with the part design and the sketcher. Part design is probably where you're going to spend most of your time if you're just designing simple little parts. It has the tools that we need for designing a single easy part, and it's where you're going to be. So let's start. We're going to do a new file. We're going to do a parametric part. I click that and it sets us up. Over here on the left, we see the part tree. This is where all of our steps are going to be. This is a parametric program, which means we build steps upon steps, and we can go back and make changes to an earlier step, and everything else will recompute. That's the beauty of a parametric program. And it's going to build a tree over here. You'll see it building as we go, and we'll be coming over here to rename stuff as we go. And we'll be referencing things over here as we go. Okay, so we have created a new part. We have a body. That's a piece of the part, and we need to create a sketch. You always start in 2 dimensions, and then you expand it into 3 dimensions. And I like to think of the coordinate system here like my 3D printer, okay? So we've got X going left to right. We got Y going front to back. I think about my 3D printer bed. And you can actually see over here on the cube, if I go to the front view, then we got Z going up, X is going left to right, and Y is going front to back. Down here in the lower right corner, there's always a reference. This is the access cross. I have it turned on so I can see it because we're going to be using this origin point here in the middle in our design. Okay, so let's create our first sketch. This is up here, create a sketch. Each of these tools has a tooltip when you hover over it, but you get used to the pictures after a while. So we're going to start a sketch inside our body. It wants to know where we want to do this sketch, and we're going to do it on the XY plane, which is like the printer bed looking straight down from above. Top view, upper right there. Okay, now I know the basic shape that I want. It's going to be a big part up here and a smaller part out here where the carabiner goes through. So that's kind of a slot shape with one end bigger than the other. So I'm going to start with a slot. And that's this here, create a slot. I'll click that and I'll come down and I'm going to hover over the middle point until it highlights. There we go. And to the right of the pointer there, you can see a little cross that appeared, there's 4 lines and a dot. That is a coincident constraint. That means that dot, or that start point, is going to be constrained to this dot. And this is the center point, the origin, and we're going to be using this for our big circle, and you'll see why when we get to doing the threads. So I'm going to click, and I'm going to draw this out. Distance between the 2 center points, I've already figured out that I want 25 millimeters there for my carabiner to clear that outer edge of that pipe fitting. So I'm going to put 25 in there. And then that is an angle. We don't have to worry about that. I'm just going to click. Okay, so I've drawn my slot. I've got this distance defined here. I need to set the radius of my circle, of my big side. And I've already figured out I want 5 millimeters of material on either side of the hole for strength. So that's 10 plus the diameter, which was 24.6, right? Or 24. So I'm going to say 34 for this diameter, half of which would be 17, right? So dimensioning tool here. This lets you dimension anything. It just chooses the dimension for you that guesses right usually. Okay, we want radius. And this is going to be 34 diameter, so 17 will be the radius. Okay. Now I need to set this one over here smaller, but I can't because right now we're fully constrained, which means the geometry is locked down. Now you can see the constraints here. That's a tangent constraint between this line and that arc. This is a horizontal constraint, and that's what's keeping us from changing this diameter over here independently of that one. So I'm going to delete that constraint. I'm going to click on it to highlight it. It turned green. I'm going to hit the delete key. It's gone. We're no longer fully constrained, but now I can move this around because that's no longer constrained to horizontal. I do want this point on this line though. Let's see. Let's do this first. Let's get the other constraint out of here, which is this equal constraint. That means that this arc is equal to that arc. So this radius is being applied here because this is equal to that. So I'm going to delete that equal constraint too. Now I've got some mobility here. I can make some changes on one end of my slot. Unfortunately, I can also move this around, and we don't want that. So I'm going to add a constraint. Constraints drove me nuts the first time I looked at FreeCAD. It just seemed like an unnecessary requirement, but now I see them as a tool. I want to make sure that this doesn't move. I want it to stay in line with this over here. So I'm going to do exactly that. I'm going to select that one, turn green. I'm going to select that one, got them both selected. And I'm going to come up here and I'm going to constrain horizontal so they will be in line with each other. Now I can't move that. But I can still change this, which I want to do. We need to set this radius smaller than that one. I've already figured out I want a 24 millimeter diameter here to give me material around the hole where the carabiner's going through. It's going to be an 8 millimeter hole. So I am going to set this radius to half the diameter, or 12. Okay. This is the outer profile of my part, and it's turned green because we are fully constrained. I'm going to close this task over here on this window down here. This is the task that we're doing currently, and any data that's related to it. There's all our constraints and things. We'll be revisiting this later. So I'm going to close this, close my sketch, and now we are back out. Remember I said we were going to visit this tree over here on the left. Well, right here it just says sketch. But as we build the model and there's more items here, it'll be convenient to rename this so I know exactly what each element is. So I'm going to right click on it and rename, and I'm going to call it main body sketch. All right, let's give this some thickness. Up here on the left, see this little tool that has a cube or rectangle floating over an empty rectangle? Pad. That's going to extrude this sketch. Pad it out as it did, and the default down here on the left, pad parameters. Down here in the window is where you find parameters on everything. We'll be revisiting this spot often. The length of it is 10 millimeters by default, which is fine. That's what we want. So, okay. Now I've got the body of my part, and it's the right thickness. I need to put holes through here. So I'm going to click on this face to highlight it. You can see it turned green. And we're going to create a sketch on that face. So I come up here to the Create a Sketch tool again. It reorients us so we're looking right down on the part. This is the face, so we're looking down the normal, which is the Z. And I want to create a couple of circles here. Now I can center my circle on this one because I used that center dot to create this arc. Remember, this part of the body. But over here, I don't have a dot. How am I going to center my circle over here? I'm going to use a tool, this little box up here with the dots and lines over it, create external geometry, create an edge linked to an external geometry. That's going to import something into my sketch that I can use as a reference. So I'm going to click that tool. I'm going to come down here to this arc. See how it lights up? And I'm going to click. Now I cancel the tool by moving my mouse pointer out here to the open space and hitting the right mouse button. Now what it did is it brought in this dotted line. Let me go hide the pad over here in the tree. If I click on it and hit the space bar, you can see the little eyeball got a slash through it, and it's hidden over here. It's still there, we just can't see it. But now we can see this reference geometry that I brought in. This is not part of the sketch. This is just a reference to that external geometry, and it gives us the center point of that arc. So now when I make my circles, I've got something to center it on. Speaking of that, we'll go up here to the circle by center point circle. Select that, and we'll come down here and we'll make our first circle. I'm going to move over this dot until I see that little point constraint appear, and I'll drag out, and I'll put in my diameter. And remember, I was going to target the bigger end of the tapered part, which was 24.6. So we'll go 24.4, sorry. I don't know if I said 6 before, but it was 24.4. I'm going to go 24.6. I like to give a couple of tenths of a millimeter clearance on my parts. 3D printers are not all super precise. And if I made an inner diameter the same as an outer diameter, you wouldn't be able to fit one part inside of another because they would be the same size. So I always add some clearance. So the thread diameter was 24.4. I'm making it 24.6 to add a little clearance. And cancel the tool. Move this out of here so it's out of the way. We'll go back to our center point circle and we'll make this one. This is where the carabiner is going to go through. And I know I want that to be 8 millimeters. Tab, enter. Right click to cancel the tool. And I'll pull that dimension out. Now let's go over here to the tree. I'm going to click on the pad and I'm going to press the space bar to make it visible again. So you can see what we've done. These are going to be our holes. Over here under tasks, I'll hit close. And we're back out. And we have another sketch, sketch 001. Again, I'm going to rename it. I'm going to call it Holes Sketch. Speaking of renaming, let's rename that pad Main Body Pad. Okay. All right. I'll click on my holes sketch to select it. We've got our holes. Now we need to make them holes through this material. That's called a pocket. It's right here. It's this little rectangle with a hole in the middle of it. There is also holes. This has some capabilities for making threads, but there are only certain selections of standard threads, mostly metric. So I'm not going to use that. I'm going to use the pad or the pocket, and I'm going to make sure it goes all the way through the model. So down here under tasks, pocket parameters, length is 5 millimeters by default, but our part is 10 millimeters. So I'm going to change that to 10 millimeters. And you can see the holes are going all the way through. Okay. We've got the basics of our part. Now it is time to do the threads. Well, here we are ready to make our threads. For those of you that are just joining us that skipped ahead, I have created the body of the part. You can see it here. And we are going to get ready to cut some threads into it. We're going to sketch a profile for our thread first. And just a quick recap, what we determined through calculation is this is the profile of the thread. As you can see, it is a triangle. And we've calculated out the pitch of it. So it's a US part, 14 threads per inch, gives us 0.0714 of an inch is the pitch, or the width of the thread. I converted that to millimeters because I like to design in the metric system. You can design in whatever measuring system you like. I'm doing it metric. So I converted that and we got 1.814 millimeters for the pitch of our thread, which is the width. And we got a depth of the thread of 1.25 millimeters, 1.25. Okay, so we know what we're doing for our thread. Let's make it. Now, Earlier, when I was creating this part, I said it was important that we use the origin point here for the center of our big hole. Always try to use that if you can when you're making a part, because later on, as you can see, the Z axis goes right through the middle of our hole. So when we revolve our cutting tool, we have something to revolve it around already. But we need to make our thread profile. I'm going to come up here to the tree on the left and see the origin. I'm going to reveal that for a minute. And you can see that we've got planes here. And the Y and Z. Y and Z, I think, is the plane that I want to sketch my thread profile on. It goes right through the middle of our hole, so I can sketch my thread profile right there, and that makes for a nice reference. Okay, I'm going to spacebar on the origin over here to hide it. Y and Z is where I want to make my sketch. I'm going to click out of here, so there's nothing selected. I don't want to attach my sketch to the origin. I want to attach it to a plane. We'll come up here to the Create a Sketch tool. Come on, tooltip, there we go. Select that. And I'm going to put it on the YZ or YZ plane. That one. And I hit OK. And we are ready to sketch. Tilt this slightly down so you can see what we're doing here. I'm going to create my thread profile right here at the edge as if it's a tool that we're going to be running through the middle. That just makes it a little clearer. So we're going to create our triangle. I'm going to use the polyline tool up here. And I'm going to make a triangle. Just quickly sketch one out. One line there, one line here, and then I'm going to bring this up until I see that highlight and the little coincident icon appear there, and I'm going to click. So I closed that. All right, I'll right click to get my mouse pointer back. This is our thread profile. Now we need to constrain it. Remember I said constraints are a tool. Don't think of them as an annoyance. Think of them as a tool. So for a right triangle, this line and this line need to be of equal length. So I'll select them both, and I'll come up here to the equal constraint. And then this line is already constrained vertical. You can see it there. So that's not going to change angle, but we're changing our height. So we need to constrain our height. I'll select this point and this point, and this is going to be our thread depth. Now constrain a horizontal distance. Now remember, that's a distance in the horizontal direction between these 2 points. It's not the distance in a straight line. It's a height. And our thread height was, do you remember? 1 1/4. So 1.25 millimeters. That's our height. Now, pull this out of the way. Our pitch, which is the width of the base of our triangle. So I'm going to select this line. I'm going to come up here to the constraints, and I'm going to constrain the distance of this line. Fix the length of a line. So I'll select that, and it's, let's see, what's that? What is it again? Do you remember? 1.814. 0.814 is the pitch of our threads. Boom. Okay, now our triangle is constrained. I can move it around, but I can't change it. And we need to move it into position. So it's going to be, I'm going to put it just outside the hole here, okay? But I need to do one more thing. I need to constrain the depth of our cut relative to the wall of this hole. I want the back of this thread just slightly outside of the wall of this hole, so when it spins through it, it cuts a uniform depth into that wall. Now, remember from when we were creating this part, how I imported geometry? We're going to do the same thing. I'm going to import this circle into my sketch as a reference. So I'll come up here to this tool that says Create External Geometry. It's the little box with the dotted line above it. I'll select that, and I'll come down here to this circle. See, I'm selecting just that edge. Click, and there we go. Now I'm going to right-click out here to get my mouse pointer back. And you can see we've got this line that goes through the middle of that circle and a point that references that circle. I could set a distance between the back of my tool and the center line over here, and that would accomplish the same thing, except if I ever changed the diameter of this hole. If I increased the size of it, our tool wouldn't move and we'd be cutting a shallower thread. I want our tool to always be a certain distance from the outside of this hole. So if I change the diameter of the hole, the tool will move. So what I need to do is set a horizontal distance between the back point and this point, which is the edge of that circle. So I've got them both selected, they're both green, and I'm going to come up here to the constraint tool, and I'm going to constrain a horizontal distance between the two. And I want that to be just outside of the wall of this hole. So I'm going to go 0.01. So it'll be just outside. Watch the triangle move. Boom. See it move? So now it is always going to be 0.01 millimeters from the outside wall of this hole. I'm going to move it just a little bit closer, but I'm going to leave it outside. We're going to spin it down through a helix and cut our threads into this hole. So we've got our thread profile fully constrained. Pull these out where you can actually read them. There we go. And we will now close this sketch. Come down here to tasks, close this sketch. It's saying under constraint, 1 degree of freedom. That's fine. That's because I can move it like this. But I'm not going to worry about constraining it. It doesn't really matter. We'll close our sketch. Okay, now we can see we got our thread profile sitting there, ready to cut some threads for us. All we need to do is spin it around this center axis as a helix. Now I'm going to rename this again. Remember, I rename everything in here so I can keep track of what's what later. And we will rename this sketch to Thread Profile Sketch. Okay, I've got him selected. Now we need to make our helix. There's 2 sets of tools here, the yellow ones and the blue ones. The yellow ones are additive tools. They add material. So there's a helix here, but if I hover over it, additive helix. This would add material. So if we were making threads on the outside of a cylinder, we would use this because we would be adding the threads. But we are cutting threads out of the inside of this cylinder, so we want to use this tool, which is the subtractive helix. I'll select it, and you can see FreeCAD has already guessed. Yes, I know. It's complaining about some things. We haven't got some stuff set yet. That's fine. It's already guessed that we want to rotate around the z-axis. And in fact, you can see that here, axis, vertical sketch axis. That's fine. That's what we want. Mode, pitch, height, angle. There's several modes here we could set. Pitch, number of turns and angle. Height, number of turns and angle. And height, turns and growth. But we want pitch, height, and angle. You can see it's going the wrong way. It's coming out away from the hole. So we're going to reverse that. If I move down here, there we go. It's a right-handed thread, which is what we want. We could set a left-handed thread if we needed to, but we don't. We want to reverse the direction of it, so I'm going to click that. And you can see it's not going all the way through. It's starting, but it's making it only about halfway through, and that's because height is only 7 millimeters. We need that to go all the way through the part, and our part is 10 millimeters. We're starting on the outside of it, so I'm going to set that to, say, 14 millimeters. There, now it's going all the way through. You can see that? All the way through the part. Good. And the last thing we need to change is the pitch. This has to match our thread pitch, 1.814. And if I hit OK, we should get threads. Look at that! We got threads. We cut threads all the way through our part. That's how you do it. Pretty neat, huh? Only thing left to do now is dress it up and print it. Let's see. I'm going to chamfer these edges, I think. So we'll pick Control, click, Control, click, Control, click each of those edges. And oops. And the ones on the bottom as well. So I'm going to hold down Control and add this edge, that arc, and this edge. And I'm going to come up here to the chamfer tool, select that. And that's a 1 millimeter, I think. Let's see here. Over here is our under task is our data. Chamfer parameters is currently 1 millimeter. I don't know, is that a bit much? Nah, I think that looks good. We'll go with that. Okay. And then we've got the hole that our carabiner is going to go through. I'm going to chamfer that as well. Oops, I didn't control click, did I? Nope. Hold down control to select multiple edges. There we go. Yep, now I got them both. And we'll chamfer that as well. Come down here and I'll increase that. Yeah, I like that. I think that's good. I could fillet this instead of chamfer it, but when we're 3D printing and this is going to be laying on the bed, and that's a 45-degree angle, so I can 3D print that just fine. If this was a fillet, a curved corner, a fillet starts out and then curves slightly and then curves more as it goes, and those first couple of perimeters would be being laid down over nothing and would just drop off. We'd have to print supports. I can just do a 45-degree chamfer and that'll be fine. So there's our completed part. Let me close my task here with the chamfers. And we can export the part. So I've got the body selected here. I'll go to the File menu, Export. And I've already saved it, that's why it's got a name. We're going to export it as an STL mesh. You've got lots of options here. Step files are nice if you ever want to send the file to somebody and want them to be able to re-edit it. That exports all the individual steps that create this part over here in the tree. But an STL, which is a mesh, is what we'll use for our 3D printing right now. So I'm going to save this as an STL mesh. And we can go to Prusa Slicer. And I can import my file. There's my part on the bed. Now, some considerations for printing. Get out of that. You can see the threads in there if you really look. See them? If we look at the bed here, we don't have a lot of space. I'm going to come up here, 0.2 millimeters, generic PLA. I'm going to slice it so we can take a look at what we got. And we'll come down here to that first layer. And yeah, you can see on this outside edge here, we've only got 2 perimeters that we're laying down. That's not a lot of contact surface. It's likely when this is printing that would lift off the bed due to the tension in this plastic as it cools. So I want to add a brim. Vertical shells, layer height, skirt and brim. Outer brim only. We'll go with a 4 millimeter brim. Come over here to the platter and reslice. And there is our brim. That will give a little extra purchase for this first layer, so it's not going to lift off the bed when I print. The other thing I want to consider is my layer height. Now we've got these threads in there. You can see that center ring kind of revolving around as it makes the threads. But if we look at these threads, it's kind of hard to tell, but we've only got 1, 2, 3, 4 perimeters per the side of a thread. Our pitch was 1.8, almost 2 millimeters is the width of the thread, which if we're going at 0.2 millimeters layer height, that's 5 layers per millimeter. That means about almost 5 layers for the side of each thread, and that's not a lot. These aren't going to be very strong, and it's an odd number, which means that perhaps some of them aren't going to have a tip. So I probably want to use a much tighter, a smaller layer height, like 0.15 or 0.1. We'll use these, we'll keep our settings, our brim and everything else, and slice now. Now if we look at those threads, and you can kind of see it there, now we've got 1, 2, 3, 4, we've got twice the number of layers per thread. And that's just going to make these threads a lot more functional. It's going to take longer to print, but we got to think about that, you know. And these are big threads. You're not going to be able to do threads like on an M4 or M5 screw. They're just going to be, the threads are just going to be too tiny for our printer to handle it. So I'm going to print this out, and then we'll go out and we'll see if it fits. Well, there's our finished part. Nice little threads down inside there, you can see. Let's take it out to the pipe, put the carabiner on it, and see how it threads on. Okay, we're outside. Here's our part. Here's my pipe. Let's put the carabiner on it first, shall we? See if this fits. Yeah, perfect. Look at that. Just exactly what I wanted. All right, here's the moment of truth. Here's our threaded pipe adapter. Here's our part. It should go on nice and loose to begin with. Look at that. Look at that. Okay, nice and loose to begin with. Remember, it's tapered. And as we get down to the bottom, it just tightens right up. Look at that. Fits perfect. How about that? Well, there you go, my first FreeCAD tutorial. It was probably a little bit long, but I've got to get the hang of how to talk about this program and cover the right amount of detail. I hope you found that interesting and useful, and we'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.